Question 2, part 2 asks us to find the volume of revolution when r is rotated 4 times through 4 right angles about the x-axis. So that's one revolution, if you will. So what does our region r look like? It looks like this. This is y equals to half, and then we've got our y is equal to x is equal to the square root of 2 divided by a 1 take y squared. And then we're going to rotate these about the y-axis so that we get a shape that looks something, if you'll excuse my sketch, something like this. So actually it looks sort of like a spinning top, as if you'd scooped one end out of it, right? So that's what we're going to look like, and of course there are our lines. This one here is y equals to x, this is y equals to a half, and this is of course x is equal to square root of 2 divided by 1 take 2y squared. Okay, so how are we going to go about finding this volume of revolution? Well, fortunately for us, we have a formula for it, and we're told that the volume of revolution about the x-axis between a and b is the same as y squared pi dx. And if you want to think about it, all we're doing, dx now becomes a slight change in the x-axis, and y becomes the radius of a circle, of a cylinder going around the axis, right? So you can think of this as summing up a whole bunch of little cylinders of radius y. Okay, so what is that going to give us? Well, what we're going to do is we're going to split this into 3 sections. First section is going to be from here, 0, to here, a half, and we're going to integrate y equals to x. The next section, I'm going to go from a half all the way up to 2 here, and I'm going to integrate this one, y equals to a half. And then because I've accidentally added in this little, this sort of scooped out part, I'm then going to subtract away the volume from root 2 to 2 of y squared, where subtract away the volume from root 2 to 2 of this function here. Right? So let me write that out. That means that my volume of revolution, my volume that I want, is going to be the integral from 0 to a half of pi y squared, where y is x, so pi x squared dx, plus the volume from a half to 2 of y is now equal to a half, so this is going to be pi 1/4 dx, and then I need to rearrange this last one to find out what y squared is going to be equal to. So I know x squared is equal to 2 divided by 1 take 2y squared. 1 take 2y squared is equal to 2 divided by x squared. 2y squared is going to be 1 minus 2 over x squared, so y squared is going to be a half minus 1 over x squared. Okay, so that means this last area that I'm going to subtract away from root 2 to 2 is going to be y squared, which is 1/2 take away 1 over x squared dx. Fantastic. So this is what I need to solve. Let's do it. Integrating, I'll just bring the pi at the front for the moment. If I integrate x squared, what do I get? I get a third x cubed, and my bounds are 0 and a half. If I integrate, again bring the pi at the front, if I integrate a quarter, I'm just going to get a quarter x, this time between a half and 2. And then, oh sorry, I also forgot the pi here, didn't I? So this should have a pi dx. Again, bring the pi at the front. What do I get? Integrate a half, I get a half x. Integrate negative 1 over x squared, I get plus 1 over x. And this is between root 2 and 2. Right, so let's start evaluating these. So pi, let's just bring it out the front for everything now. Substitute in a half, So a half cubed is an eighth times 1 over 3. This will be 1 over 24. Substitute in 0, 0. So minus 0, right? Plus, okay, this one, I substitute in 2. 2 times a quarter is a half. Then I have to take away what happens if I substitute in a half. I get a quarter times a half, which is 1 over 8. Minus, this one, I substitute in 2. What do I get? 2 times a half gives me 1 plus 1 divided by 2 is a half. Minus, substitute in root 2. What do I get? I get root 2 over 2 plus 1 over root 2. Okay. Good to know. So, let's keep going a little bit further. The pi is still at the front. Let's simplify this expression. This is 1 over 24 plus a half take an eighth is going to be 4 eighths minus 1 eighth, so it's going to be 3 eighths, minus 1 plus a half is going to be 3 over 2, and then minus, well actually root 2 over 2 is the same thing as 1 over root 2, so this is two sets of 1 over root 2's, or 2 over root 2, which is the same thing as square root of 2 itself. And minus a negative will give me plus square root 2. So this is my expression. Now if I just put these all to the same denominator, what do I get? I get 1 plus 9 minus, change this to the denominator to 24 multiplied by 12 top and bottom, minus 36 over 24 plus square root 2, or in other words I get pi, this is 10 minus 36, so minus 26 over 24 plus root 2, that's equal to pi root 2 minus 13 over 12 units cubed. And we are done.